Hi everyone. Happy Friday, or whenever you're watching this. We're doing Unit 6, Lesson 6 today. We did Lesson 5 practice problems yesterday. And Lesson 6 is the last lesson we're going to go ahead and do of this unit, even though there's more to do. I didn't print them for you, but this is the bulk of what we need to get out of Unit 6. And then on Monday, I will give you guys a new unit, Unit 7. And we'll get that up and running. But for now, we have been taking a look at associations in data. There's positive associations, there's negative associations. Obviously, positive means going upwards from left to right. Negative associations mean it's going down. And we've noticed that you can make a line that can take an average of all those scattered plots and then give you some data. And today we're going to actually, it's a bit of a review because we've talked about lines and slopes and how to calculate that. And on the other hand, we're applying it to scatter plots. So we're just putting an old concept with a new concept, and hopefully some light bulbs will go off. And if not, great, then relearn the material, and that's fine too. So first off, 6.1 says estimating slope. It says estimate the slope of this line. So we have to just try to guess. And if you remember, slope equals rise divided by run. So you got to pick 2 points on this line and figure out the rise divided by the run. Lots of ways to go about this. It does say estimate. Here is a point that is almost on the line, and here's a point that is almost on the line. So if I were to do the rise and divide it by the run, I could get something. Well, do you remember which of these numbers? There's a 5 and a 2 and a -4 and a -6. The rise numbers are these right there. That's the y-axis, the y right there. Those are the y. The second number is the y. So I'm going from a -6, all the way up to a +2, which means I'm going up 6 plus another 2, which means my rise is 8. I went from a -6 all the way up to 2. If I really wanted to do this mathematically, finding the rise and the run, if you remember, is taking the y value, the difference between the y values and the difference between the x values. The difference means subtract, and the other one was a -6. 2 minus a -6 is the same as 2 plus 6, and you get 8. I took that 2 and subtracted that -6. So the rise is 8. The run, on the other hand, is going from a -4 all the way over to a 5. So again, if I subtract the differences, if I went from a -4 to 0, that's going over 4, plus another 5. So that's 9. 5 minus -4. The difference is 5 plus 4 minus. So I still get 9. So guess what? That's not exact, because if you notice, these dots are not on the line, but it says estimate. So to me, 8/9 is a decent estimate. If anything, it's slightly less than that because the line looks like it's not quite as steep as that. If I actually connected these two, it would be slightly less steep. So I could say 8/9. I could maybe say 7/9 or something. But that was a good warm-up because we're going to be talking about slope today. 6.2, describing linear associations. For each scatter plot, decide if there's an association between two variables and describe the situation using one of these sentences. For these data, as blank increases, blank tends to increase. For these data, as blank increases, blank tends to decrease. For these data as blank and blank do not appear to be related. So there's 3 bullet points and there's 3 graphs. So one of these graphs, I always start with the easiest, process of elimination. One of these graphs, there appears to be no relationship between, this first one is price and mileage. It looks like there's definitely an association there. There's a tendency. Price and weight in carats, they're talking about some jewel of some sort. I can see a positive association there. I can see a negative one in the first one. And this last one, to be honest with you, I kind of see one, but technically there's not supposed to be one. You could kind of say maybe it's going up, but there's too many outliers that kind of throw it off. So that last one says for these data, blank and blank do not appear related. It says energy consumed and high temperature. So we would write energy consumed and the high temp. Hope you're listening because my writing is not great, but on the other hand, if you remember, I'm kind of doing it on purpose. I don't want you guys to think that copying down what I write is necessarily a good habit to get into. So those 2 don't appear, which is weird. Energy consumed and high temperature. Usually, well, I guess it says high temperature, but not like total temperature. Usually, the higher the temperature, the more energy that's consumed. But maybe it's just saying something like high temperature, but who knows? That's the only one that logically fits there. So now, something says as blank increases, blank tends to increase. As something increases, something tends to decrease. Well, this line I can see is going upwards. It looks like as something increases, the other thing is also increasing. So we have to decide, do we want to say as price increases, the weight, or as the weight increases, the price increases? I don't think it matters which way we say it, but I would definitely say for that top dot, for these data, as the weight increases, the price increases. Think about it as the weight of a diamond increases, so does the price. And you can see it's a scattered plot because it's not exact. Different stores charge different things. Maybe there's different clarities in the jewels, whatever. Who knows what they're even measuring. And the next one says price and mileage. As the mileage increases, what happens to the price? As blank increases, well, just like a car, I think they're talking about a car. As the mileage increases in the car, the price of the car goes down. The more miles on a car, the cheaper it's going to be. And that's about it. That's kind of a little bit of a review in the associations and data that we kind of talked about the last day or two. Now, for the real meat and bones of the lesson, interpreting slopes. For each of the situations, a linear model for some data is shown. A linear means a straight line. So notice there's a bunch of dots, but they went ahead and made a model, a straight line. What is the slope of the line? And then 2, what does the slope even mean? That's always the most important thing. What does it even mean? And as usual, this curriculum doesn't print very friendly when it's converted to the PDF format or whatever it is. So you can see, I'm going to rewrite this. The equation for this first equation goes 5520 0.619x minus 1091.1.393. Now they are getting very, very technical with their equation. And so be it. But the first one, wait, this is weird. I thought we were going to have to calculate some rise over run. I thought we were going to have to pick 2 points. On the other hand, looking at this scatter plot, looking at this, we couldn't be exact. We could pick this point here, and that's the only other point that's exactly on the line. But even then, I don't know exactly what that is. It looks like it's roughly 5,500, and it's roughly 1.2 something. But I realized to calculate rise or run, you need actual exact numbers. We don't have that. They gave us this equation. This one goes with this one. That equation goes with that. And this equation annoyingly goes, I'll rewrite it down here, y equals 0.59x minus 21.912. So when we get to that one, we'll take a look at that. So how are we supposed to calculate the slope and find the meaning of the slope when all they did was give us this equation and then a bunch of dots that don't even fall on this model? I think they made a mistake somewhere. Just kidding. Guess what? That equation is staring right at us. It's telling us the slope. Guess what? It's right here. The slope of this line is 5520.619. It's the number, remember that we have what we call y equals mx plus b. And they're even writing it in y equals mx plus b format. That's called slope format. The m is the slope, or the movement is, I don't like it when it does that. The movement, right, or the slope. The b is the y-intercept. You don't need to be writing this down, although it never hurts. That's the y-intercept, or b is the beginning. It's where it crosses. It's where it crosses the. Go away. There. Oh no! Oh phew! Ay, ay, ay. That was a close one. So, guess what? What is the slope? 5520. There it is. That's the easy part. Well, kind of, sort of, once you remember that, hey, the number that's attached to the x is the slope. And the slope gives us a rate. It's a rate of change. It's a unit rate. It's something per something. And the slope always has to do with the price and the weight. Not always. I'm saying for whatever the situation, it has something to do with the x and the y axes. It has something to do with that label. So it has something to do with price and weight. It has something to do with price and weight, or weight and price. And if it is the rise divided by the run, then it is the price divided by the weight. So slope has something to do with price over weight. And the weight is in carats. So can you make a guess on what the slope is? If you guessed right, let's switch back to a darker color. It's kind of suggesting that it is, and the fact that it says 0.619, you could round to 2 and call it, but that's kind of like gas. You don't notice it, but they do charge you 1/10 of a cent. Just like this is suggesting charging 1/10 of a cent. But what it's saying is $5,520 per carat. The weight is in carats. Again, I always wondered, how much does a carat weigh? carat is 0.2 grams. Fifth of a gram, okay. So, per carat. So for 0.2 grams, it's $5,520.62 if we round it up per carat. So when the question says, what's the slope of the line? Well, apparently, that's easy. They've given us y equals, we're going to be able to find the slope in 2 seconds. Now, finding the meaning, well, we're going to have to look at the graph and the x and the y axis label to figure that out. And we just did that for number 1. Number 2, go ahead and put a big box around the slope. You can clearly see that the slope is going down there. The slope is that negative 0.011 going down. So something is going down. So what does that even mean? Well, it has something to do with fuel efficiency and weight, or the miles per gallon and kilograms. So let's try to interpret that more. Let's think about this. As the weight increases, it goes from 1,000 to 2,500. As that goes up, I can see the fuel efficiency, the miles per gallon, goes down. So as a car gets heavier, its miles per gallon, on average, goes down. There are exceptions, of course, with aerodynamics and the type of vehicle, the type of engine. But that's the whole point of a scatter plot. It's saying there's lots of different types, but there's a tendency that says it goes down. So that negative 0.011 means something. It has something to do with miles per gallon and kilogram. It is 0.011 miles per gallon, this is kind of weird, per kilogram. And it's negative per kilogram. So I kind of wrote that 0.011 miles per gallon, 0.011 is the slope per kilogram. And it's negative. So what do you think that means? It's saying that it's every kilogram that you add per kilogram, every time you add a kilogram to a car, 1,000 grams, your miles per gallon goes down 0.011. So if you added a kilogram, no, you're not going from 30 to 29. You're going from 30 to 29.999 or something like that, 989. Yeah, something like that. So it's not, a kilogram for one is not much to add to a car. So it is going down. It says interpret the slope. It says it's going down 0.011. A car or vehicle will go down 0.011 miles per gallon every time a kilogram is added to it. And then finally, 0.059, I went ahead and wrote that down there. X minus 21.912, energy consumed and high temperature. You saw that last one. We didn't really say, we had to say one of them didn't have an association in data. For these data, energy and temperature do not appear related. Oh, you know what? I know why. I didn't read that question very well. But that's okay. I'm glad that I just looked at it and I'm thinking. My brain is engaged. It says for each scatter plot, in the very first assignment, 6.2, describe the situation using one of these sentences. There's this sentence. There's this one. We didn't have to use all three. In fact, we didn't need to use that one. Because like I said I thought I saw a positive association, and sure enough, looking down here, same graph, there is one. They did draw a line. So we probably should have. In fact, we need to change our sentence for, we shouldn't even use this one, and we should have been writing sentences otherwise, but we do need to say that there is a positive association. As something increases, something else increases. So I'll let you change that. You need to pause the video if you need to, because I'm going to move on. Because I've got other problems to get to. So this one, it is telling us, it drew us a line, and we have to say, first off, what's the slope? It's staring right at us, the number attached to the x, so you can go ahead and write that down. And then, what does that even mean? Well, this energy consumed in high temperature has something to do, it's positive. Unlike the last one, when we added something went down. As we added weight, miles per gallon went down. So what does this 0.59 mean? It has something to do with energy consumed in high temperature. So kilowatt hours, or 0.59 kilowatt hours per, it says high temperature, per degree. So you could say something, what does the slope mean? It means every time I add a degree of temperature, every time I add 1 degree, kilowatt hours goes up 0.59. Kilowatt hours is a type of way to measure energy that you're consuming. It's like how much electricity you're drawing from your power line. You're sucking in electricity from your power line, and usually when your air conditioner is running, your kilowatt hours goes up and goes down when you're not using much electricity. So for every time, when it gets hotter, more and more people use air conditioners because they consume more electricity than just about any other appliance, I think. So every time you add a degree of temperature, kilowatt hours goes up by about 0.59. 0.59 kilowatt hours per degree of temperature would be a good way to interpret the slope. So that is that. There's one other problem, and it's 6.4, and this is something I don't think you're going to need my help at all. It says positive or negative. It says for each of the scatter plots, decide whether it makes sense to fit a linear model to this data. If not, in other words, decide if you could draw a line. Decide if you look at it and you're like, yeah, I see it kind of just this kind of line. This is the tendency. Then go ahead, and it says decide whether it makes sense to fit a linear model to the data. If it does, would the graph have a positive slope, a negative slope, or a slope of 0? So if you are, well, for one, you can draw a line if you'd like. That helps you see if it's positive. And or it says decide whether it makes sense to fit a linear model to the data. For A, yeah, I see that. For B, yeah. C, yeah. E, yeah. D, I don't know what's going on with D. So, go ahead and for each one, decide if it has a positive, a negative, or a slope of 0 would mean it's going straight across. D is, yeah, I wouldn't call it. That says if it does. I think D would be the one that we would say there is not a linear model that represents D. That's just going all over the place. Who knows what that's even graphing. But A, B, C, and E, I think you could say that there's a linear model, and then you could just say, you just write positive, negative. I don't see a slope of 0 anywhere, so you can leave that off. And then 2 says, which of these scatter plots show evidence of a positive association between variables or negative association, and which do not appear to show an association. So you kind of answer that just by simply answering which have a positive slope or negative slope. So it's kind of redundant, but so be it. I'll let you do that on your own. When you are done with that, you might want to hit pause now, because I'm going to jump. I'm not going to do all the homework for you. But I think you can do number 1 without any help. That's kind of just what we did. Number 2, again, I think you could do that one. Number 3, I think you can. I don't know why I ever doubt anyone. But I will help you. Let's look at number 3. And 4, I think you can do. And 5 is always, let's go ahead and do 5 together real fast. But 3, it says the linear model for some butterfly data. And by the way, I still want you to do the other problems. So just because I'm not doing them doesn't mean I'm not going to give you credit for doing them. The linear model for some butterfly data is given by the equation y equals 0.238x plus 4.642. Which of the following best describes the slope of the model? So it looks like as the body length is the y-axis going up and down, and the wingspan. So as the body length gets longer, the wingspan also gets wider. And I can see here this 0.0238. That must suggest the body length per wingspan. As the body length grows 0.238 millimeters, the wingspan is 0.238 per millimeter. Body length and the wingspan also grows by 0.238. For every 1 millimeter the wingspan increases, the length of the butterfly increases 0.23 millimeters. For every 1 millimeter the wingspan, the length of the butterfly 4.62. Well, they're trying to trick us into looking at that. We don't want to look at the 4.62, so I don't think it's that. That's the y-intercept. That's kind of suggesting that's like the initial length of a butterfly or something like that. And again, let's not let that trick us. So it's between A and C. For every 1 millimeter the wingspan increases, the length of the butterfly increases 0.238. Or for every 1 millimeter, the length of the butterfly increases, the wingspan increases 0.238. I believe since we're doing body length, we're doing rise. Rise is body length divided by wingspan. Rise divided by run. This is the rise, this is the run. Body length divided by wingspan. The wingspan is going to be the 1. Whenever you do something divided by something, the denominator always ends up with a unit value, meaning the denominator is 1, and then you have a number up here. You have a number up here, and then that denominator. So you end up being 0.238 over 1, which means the wingspan is the 0.238. For every 1 millimeter, the butterfly increases, the wingspan increases. The body length is the 0.238. So it's got to be A. And then number 4, I think you can do nonstop one-way flights from O'Hare in Chicago, and prices of a one-way ticket are shown in the scatter plot. Circle the outliers and use the graph to estimate the difference between any outliers. I am just about every day waiting for flights to open up from O'Hare or St. Louis, or preferably Peoria, because I gotta buy my plane tickets to Arizona for Christmas. And if I do it on the first or second day that they come out, man, I save myself like $1,000. Nevertheless, you got that one. Number 5, solve this. If y equals that and y equals that, then we set these equal to one another. I love solving this. I don't know what it is. So step 1, whatever. We could add 3x, we could subtract 13, add 2x, or subtract 1. It doesn't matter. I'm going to add 3x because then I get rid of negatives. Negative 2 plus 3x. Well, these cancel. I'm left with 13 on this side. Negative 2 plus 3 is just 1x, which is great. That's what I want. X plus 1 is 13. Well, that's easy. X is 12. Subtract 1, subtract 1. X equals 12, and I'm done. Not really. A lot of us always quit there. But we also have to figure out, what does y equal? I got to plug x. I got to plug this 12 anywhere. I can plug into that one or the bottom one. It looks a little easier. That means I got to do a negative 2 times 12 plus 1. That's what y equals. I get a negative 24 plus 1. And y equals negative 23 then. So I got to circle that. I got to circle that. Now it's a freebie for, maybe you pause it, who knows. But that's a little bit of a review there. So go ahead and finish the rest of this. And that's it. Have a fantastic, great weekend. And we'll get rocking and rolling with some Unit 7 when you get back, some exponents, some scientific notation. Jeez, I couldn't think of the word. It's time for me to go to bed, but I've got another hour or two of reading to do. Wonderful. Peace.